Hi everyone. So in this question, we are basically given an array of squares which lie on a 2D plane and they can be scattered anywhere on a 2D plane. We are given their starting x and y coordinate along with the length, and those are basically bottom left point and the side length of the square parallel to x-axis. So we have to find and the squares can overlap. So we have to find a line where the area of the squares below it is exactly equal to the area of the squares above it. And if there are multiple possible lines, then we have to select the lowest possible lines. Now, since we need to calculate this using floating, we need a floating point precision here. We can use binary search on the space. So if the squares overlap, we can calculate the overlapping areas multiple times. So this is how the question is. And yeah. So basically what we've done here is we have some variables, which is like low, high, total area. So what are we doing here? We are basically calculating the total area of all of our squares in the search space. So then when we are also calculating the maximum y height in our search space of all the boxes or all the squares. So that is what we have done here. And then we calculate our target area. So that's why we divide it by 2.0, which is like a floating point division. And then we use binary search on the space and in the end return low. Now, since we need floating point precisions, we've run this 80 times so that we get to a very the lowest possible y value, and also avoid running into infinite loops because of floating point arithmetic. So what we've done is we have calculated the area below this middle line. So if our area below this middle line is less than our target area, it means we've chosen our low is too low. So that's why we have increased low to mid. We have increased our low. Else we have decreased our upper bound. So we go up till 80 times to get the precision in our floating point answer. And then here what we've done is I've calculated area below the guessed line. So what we're doing here is so there's this middle height. If my square is, if my box is entirely below this height, then we calculate the entire area of the box, which is length into length. But if my middle height somewhat cuts the square, it means we have to calculate the bottom area, which is like middle height minus lower y. And we multiply it into with length. And in the end, we return the calculated total bottom area. So coming to the time and space complexity, in here we basically iterate for big O of n times. How big O of n? We basically have this. If let's say we have n number of squares, so this loop is going to run for n times. So big O of n here. And this is we're calculating a target area, and then this loop runs for 80 times. So this is big O of 80. And then in here, calculate area below guess. So let's see what's the time complexity for this. So in here, we actually run this for n number of times. If n is the number of squares that we have. So the time complexity is big O of n here. So the total time complexity for this block comes out to be 80 into n. Now, since 80 is a constant, we can say the time complexity of this is big O of n. The total time complexity is big O of n as well. And now coming to the space complexity, the space complexity is big O of 1. Why big O of 1? Because we are not creating any additional data structures or using arrays, heaps that scale with the size of the input. So that is why our space is big O of 1, since we are using just a scalar value, some few scalar values to track the lower y height and the upper height of, I mean, the upper value of y and then the total area. So yeah. So yeah, that was it from my end. Thank you for watching. Bye.